and welcome to my presentation on atomic structure. To find the number of protons, neutrons and electrons in any element, so I will be using phosphorus as an example. This top number here is called the atomic number, and this shows us how many protons are in the nucleus, and for phosphorus this is 15. The atomic number also shows us how high up the element is on the periodic table, so as we can see we have number 15 there. And at the bottom here we have the mass number, which shows us how many protons and neutrons are in the element. So the number of protons we have is 15. We then need to take this away from the mass number to get our number of neutrons, which is 16. And to find out how many electrons they are, well, being an atom is neutral, this means the protons is the same number of electrons, and this is because with the atom being neutral, the positive charge cancels out the negative charge, so protons are positive and electrons are negative. Just to know, most of the mass numbers on elements will need to be either rounded up or rounded down. As discussed, an atom is neutral. However, should this gain or lose electrons, this is then called an ion. An ion is something that gives off charges. So should it gain more electrons, this becomes negatively charged, and should it lose electrons, this is positively charged, and this is all due to the imbalance of these electrons and protons. So for example here we have chlorine, which has 17 protons and electrons, and it is gaining 1 electron. So as we can see, the imbalance here means it is negatively charged as there is now more electrons. Now here we have sodium, which has 11 protons and electrons, and it is losing 2 electrons, so it is becoming more positively charged. Electrons are distributed in shells surrounding the nucleus. Electronic configuration is used to show how many electrons are in each shell. You can have a maximum of 4 shells in each one. Not all elements use all 4, but I'll be using potassium here as the example, as this is one that does use all 4 shells. So there's 19 electrons in total. The third shell can hold up to 2. The second can hold up to 8, the third can also hold up to 8, and the fourth shell can hold up to 2 electrons. So we would write the electronic configuration for potassium here as 2881 to show how many electrons are in each shell. Just an example with boron, which has fewer electrons, 5, so this would be distributed as so. To orbitals. Orbitals can hold up to 2 electrons, and they spin in opposition of each other in these orbitals, which come in different shapes. These are called S, P, D and F. So these join together to form a subshell, and this is what makes a shell. So in our first shell here, I've got the nucleus in the middle, and then the first shell around it is 1s, the second shell is 1s and 1p, and the third is 1s, 1p and 1d. Because of these subshells, you can see that shells can hold more electrons than we originally thought. By sectioning the periodic table like this, we can see which elements belong to which group. The numbers in top in brackets show us how many electrons are in the outer shell. To see which subshells are used, we have to follow this order here. Just note that 4s is closer to the nucleus than 3d. And if we use this table here, we can see which groups are used. Example, I have aluminium here with a negative charge of 13, so each one of these arrows represents 1 electron. Notice I'm pairing these off separately as these spiral up and spiral down for stability, and we write this in the following notion, as this shows us which shells are being used, which subshells is being used, and the number of electrons in these subshells. For another example here, I have zinc, which has lost 2 electrons, so it is now a zinc ion with 28 electrons. So we start filling these in. I've filled in 18 here. Remember that 4s comes before 3d, which then gives us the following notions. And now we have an oxygen ion with 10 electrons. And we fill this in just the same, which gives us the following notions.